Hello, Mrs. J here. Welcome to my class. Today we're going to do Chapter 9, the regular course for QR. We learned how to plug into the calculator last time, so this time we're going to do more problems. We've talked about, in Chapter 8, linear. And this brings it back in this section. Remember, linear equations grow by the same amount each time. So if you put 500 in an account, and make $10 per year, you're making the same amount every year. And so that makes it linear because it's growing by the same amount. Now if we wanted to write this as equation, remember the rate of change is your slope and your starting amount is your y-intercept. So y would equal our slope of 10x plus our starting amount. And that's what we had worked on right before break. This course, this section gets into exponential growth also. Exponential growth either grows very quickly or decreases very quickly, and it's not the same amount every time. So it's usually a percent. So it's usually a percent. For instance, if we deposit the 500, and we make 7% interest each year, then you're not making the same amount every year because it's 7% of whatever's in there rather than the same amount. The formula is the starting amount and then you use the 1 plus or the 1 minus trick, depending on which one it is. And then your exponent, or your percent. And you can even put an R there so you remember it's a rate. So it's your percent as a decimal. And the starting amount is also called the initial amount. And you can use 1 plus or 1 minus trick, depending on if it's increasing or decreasing. So in that example, to write the equation, our starting amount was the 500. Don't forget your R. And we are making 7% interest, so it's an increase of 7%, so it would be a plus trick. 7% as a decimal, remember move it over 2, it's 0.07. And that would be your equation. So it's your initial amount, because it's an increase, it's 1 plus 0.07 to the R. So if we wanted to know the balance after 24 months, we don't plug 24 in, because this was per year. So since it's 7% per year, 24 months is 2 years, you plug 2 in. So be careful, they will switch units around. And then you would plug that into your calculator. And that's why it's important to know how to use your calculator. Remember, this part you will need an exponent. If your calculator doesn't do it all at once, do inside parentheses, then do the exponent, and then multiply by the initial amount. If we plug this into our calculator, can't see in this light. You should get $572.45. So you do want to make sure if it's an increase, you use this one. If it's a decrease, you use this one. Exponential grows by 1%, and the other one grows by the same amount every time. Let's try a couple problems. So if we have our equation when it's exponential, by looking at it, we can find the initial amount and the relative change. The relative change is the percent, and if it's increasing or decreasing. So when you're stating relative change, you want to say whether it's an increase or a decrease and the percent. If we have the equation, well, remember the formula, the initial amount's the amount in the front, so initial is 120. Now the relative change is not 1.07. Remember, we either added or subtracted the percent. So to find it, take that value inside the parentheses and subtract 1. And then make it a percent. Since it's a positive, the relative change is an increase of 7%. There was an increase of 7%. Let's try another one. Okay, so this is a terrible S, but it's an S. So S equals 472 times 1 and 3600ths to the T, or in this case the R. The initial amount is what? Yes, it's the 472. Well, then we need to find the relative change. Remember, when you're finding the relative change, we added or subtracted this on, so we need to take the 1 back off. Subtract 1. Make it a percent. Remember, when we're making it a percent, you're either multiplying it by 100 or moving it over 2. It's positive, so it's an increase of 36%. Try another one, because of course these are all increases. We need to have some decreases in there. So if we have y equals 521 times 72 hundredths to the x. Sorry about the dog. She's giving answers. But the initial amount is the 521. It's always the amount by itself. Relative change comes from inside, the part that has the exponent on it. So take it and subtract 1. Now when we do this one, notice you're getting a negative answer. Should get a negative 28. Well, 0.28. But then we're going to make it a percent. Now it's not a negative 28%. The negative means it's decreasing by 28%. Or of. So there's a decrease of 28%. That would have then, we used the 1 minus trick, and that's how we got the 72. Try one more. So P equals 1,000 times 0.40 to the T. So we want to write the initial amount and the relative change. And remember, when you're writing relative change, you have to put that increase or decrease with it, or you will get it marked wrong. But the initial amount is 1,000. We take the part inside, subtract 1 and get 6/10. Multiply that by 100 to get our percent. Now remember, you should have gotten a negative, which means it's going to decrease. So there's decrease of 60%. We'll try one more simply because I want you to show what happens when there's a big number. Sometimes there's large increases and it seems strange. So let's try one more. Oh, I put equal. Oh, I went too far. Okay. So if we have this, write the initial amount and the relative change. This one ends up really large because it's growing really fast. We know our initial amount's 127, but when we take 3 5/100ths and subtract 1, and then remember we still need to move the decimal over 2 or multiply by 100. So it's an increase of 205%. And that can show up sometimes. I mean, it's not very likely that it happens, but I guess the value of a car could decrease by 200%. What's jewelry increases, when they take what they bought for it, the jeweler will increase it by 300%. So there are some large increases, not very many. But. Any questions? Remember to text me. You have my phone number. I want to look at a little bit more on the growth, the two different ones. If we have $1,000 and we're going to get two different possibilities. I can't spell today. So we're getting $100 a year interest, or we could put it into a different account and get 8% per year. So two different accounts, we want to see which one is better. Well, let's look at the first case. The first case is $100 per year. Is that linear or exponential? Well, it's growing by the same amount. Every year you're getting $100. Therefore, it's linear. Linear means y equals mx plus b. B is our starting amount, or the initial amount, your fixed amount, and M is your rate, the changing amount, which in this case is $100. So to write your equation, one put M. We have this. So we could find out how much is in there at any time just by plugging in. But let's look at it as if we were using our linear or our Excel file. And we're going to look at the first 4 years and see how much is in the account. Well, when we open the account, we put $1,000. Oh, we should have a start here. Because we're starting with $1,000. And then we're going to see what happens at the end of each year. Looking at case 1, at the end of the first year, there's another $100 in there. So it's just going to add $100. So we have $1,100. The second year, we're adding another 100. That's why it's linear. It's the same amount each time. So we have $1,200. The next year, $1,300. And the last, $1,400. Now, if we plug that into our formula for 4 years, we get the same thing. But if you need to show each month so that you can see how it's growing, and if you think about your statements that come in the mail, or each year, this is years, it will show you each balance each year. Okay, let's look at one that's continuous, or exponential. The second one. And we had said 8%. But we were still putting the $1,000 to start. And each year, we're adding 8%. So rather than adding 100 each year, adding 8%, which means the 1 plus trick. So it'll be, to find the percent, it's 1.08 because we want $1,000 plus the 8%. So to find our first amount, rather than adding 100, because it's a percent, we need to multiply by 1.08. And that will tell you the next value. And so if you multiply by that, you'll have $1,080. So it looks like that one makes more money. But because of that $80 in there, the next one that comes on will grow even faster than the one before, because the 8% is not on just the 1,000 now. It's on the 80 also. So when we find the second year, we multiply by our 1 plus trick, and we get the total amount as $1,166.44. So we still haven't passed it if you look at the second year. But it's getting there. When we look at the third year, again multiplying by the 1.08, you should get $1,259.71. Do it one more time. And we get $1,360.49. Now, when we work in the lab, we'll go further and see when this one will eventually pass the other one up. As of now, it's not. But it's getting close. Okay, write the equation for this. So I know like we did this one. Now, this is growing by 1%, so each time it was different. But if we write the equation, remember it's initial amount, and our initial amount was the $1,000, because that's what we started with. And then we multiply by our percent, and we're increasing, so it's a 1 plus trick. Write the percent as a decimal, and then our exponent. Now, if you wanted to get this answer, then you'd plug 4 in. If you plug in 3, you should get this one. If you plug in 2, you should get this one. I think that's it for today. At least the dogs feel that's it for today. I will see you later. Was that really bad with the dogs barking?